All right, so for problem number 29, it says for the polynomial p of x, the value p of 3 is equal to 2. Okay, so let's jot that down. Now what that means is that somewhere on the graph of this polynomial, now I don't know what it is, but there's a graph of a polynomial that looks, whatever the function is, we don't know. But somewhere on that graph, the point 3 comma negative 2 exists. In other words, when x equals 3, y equals negative 2. That's what it's saying. It says, what must be true about p of x? Okay, so now we gotta figure this out. So it says that when this is a conceptual question. So we basically have to go through and think about this. Okay? They're saying that in order for this to be true, A needs to be a factor. Well, if that's the case, then that would be x equals 5. In other words, if this is true, then that would be a 0. In other words, when x is 5, y would be 0. Well, that doesn't help us, right? This one would just say that when x equals 2, y would be a 0, right? So if you notice, I'm taking the opposite of this and setting it equal to 0 and solving. This would be negative 2 comma 0. So they're giving us zeros, but that has nothing to do with this. However, the remainder when p of x divided by x minus 3 is negative 2. So D is true. And this has to do with synthetic division. Well, it has to do with the remainder theorem, right? So what this means is that when you take p of x and you divide it by a factor of x minus 3, then that would equal q of x plus r over x minus 3. And so then the polynomial and the r is a real number. So then, well, I don't know if I want to. Can I write it? This might confuse you if I do it that way. So what you're saying is that p of x is equal to x minus 3, right? And then q of x plus r. And then, well, when that takes place, if I say p of 3, that would equal 3 minus 3, which is 0. And then we have q of x plus r, right? But q of 3, whatever that is, plus r, right? Well, that would have to equal, this is 0, q of 3 plus r equals r. Does that make sense? And since r equals negative 2, that's how we get that. That's the remainder theorem. Do you guys remember that from Algebra 2?